Hello, we are looking at a rational function, and I know that because I see the equation over here, but we have a lot of information about it as this is a real-life example. So we have an experiment on retention is conducted in a psychology class. Each student in the class is given 1 day to memorize the same list of 40 special characters. The lists are turned in at the end of the day, and for each succeeding day for 20 days, each student is asked to list as many of the symbols as can be recalled. Averages are taken, and a formula is found where n of t is the number of symbols recalled after t days. First thing we're asked to do with all this information is create a graph. So I have my function here, and I have a restriction on t that t has to be greater than 1. We're actually talking about this in our second bullet point, but we may as well discuss it now. We see that in the problem, day 1, they get to memorize everything, and then each of the succeeding days, they are taking the test. So they don't take a test on day 0, the day that they memorize, but they start on day 1. We also see that they only take the test for 20 days, and we see that there are only 40 characters to memorize. So this 20 days is our t, or our x variable, and the number of characters up here, the 40, is our y variable. So noticing all of that information should help us in creating a graph for this. So here I am at my graphing calculator, and I'm at the y equals, and I want to type this rational function. And it's super important with rational functions that I group the numerator and the denominator. So here I have 5x plus 30, and you see that I'm putting that in parentheses, divided by, and I don't need parentheses in the denominator because it's literally just x. And then I want to set up my window. So this is where I'm using the information I observed in the problem. So we are told that x, or t, starts at 1. And we're told that they do this for 20 days. So we go up to 20. And then in the y direction, we'll think 0 would be the least characters they could possibly remember. And there were only 40 on the sheet. So we'll use 40 as the most that they could possibly remember. And so we'll take a look. What does our graph look like? So we see what looks almost like an exponential curve, a nice curve coming down. It definitely does not come down to the axis. It levels off above the axis. And so we'll go back and make a sketch of that graph. So we used the x-axis as days, and we went from 1 up to 20. And this is the number of characters that they recalled. And we went up to 40. And then when we looked at our graph, and we saw that it did not come down to the x-axis, but I want us to look, where did it start? So when I come back here, it looks like it does not start the whole way up at 40. So even on day 1, they did not remember all 40 of the characters that they tried to learn. So I want to start my graph down a little bit, and I want to end before 0 with my curve. So starting a little below 40, curving, but not down to the axis. So that's what my graph looks like. They asked me then, why is t restricted to be greater than or equal to be 1? And that's because they took the first quiz on day 1. And then it asks, what would happen if t would approach 0? So that means we're going the wrong way on the x-axis, so we're going back this way towards 0. We see it's getting bigger and bigger, and it would get bigger and bigger. So if t would go towards 0, the number of characters recalled would go towards positive infinity. And how does this not make sense in the context of the problem? Well, there were only 40 characters. So I want to go back to the graph and look at this piece of what is happening as the time goes to 0. To look at this, I am going to change my window. So I'm going into my window, and I'm actually going to put this at -1 so that we can see the axis, even though that's not part of the problem. And then in the y direction, I'm going to make my y value very large so that I can see a lot. So let's go very large, 5,000. All right, let's look at our graph. So I can see here that, zoomed out that far, all I can see is that there's a blue line here, so we know that the graph was traveling here. It truly does not hit the axis, so then it comes up, and then we can see this blue line on top here. And so this blue line is going the whole way up to 5,000, and it keeps going. So as we come backwards, as we come towards 0, this graph definitely goes up towards infinity. Even though that's not helpful for the actual context of the problem, that's how the shape of the graph is beyond the parameters of the problem. So then we look back here, and it says, what is the horizontal asymptote? So to find the horizontal asymptote, we need to look at the equation, and in the equation we're going to compare degrees. So degree here is 1, degree here is also 1. Both to the first power. So from that I observe that the degrees are equal. And when I look up that in my notes, what to do when the degrees are equal, that tells me I get an equation y equals the ratio of the leading coefficients. So in this problem, y equals, my first leading coefficient here is the 5. So 5. My second leading coefficient down here is an unwritten 1, so 5 over 1, which is 5. So I switch colors here so that I can draw this on. So coming across here is our horizontal asymptote or limiting value. And that means that the graph is going to approach this, but it won't cross it. It will just get very, very close to 5. Y equals 5. And so then it asks, what is the significance of this asymptote in real life? And so the significance is that from this activity where they had to memorize these 40 random characters and then recall them for 20 days, they ended up knowing 5 of them for life. So they literally knew or learned 5 characters, which that has a pretty big impact for us as we're going into final exams week. So this particular experiment was set up where they were given 1 day to memorize. And so if you study for your final exam on multiple days, you're going to do better than if you just study for 1 day. And we also don't know that in this experiment that they had any context. And so one of the things we see in learning theory is that if you're able to make connections to other things that you know, you'll remember a lot more. So with the characters out of context, it was hard for them to remember them. But even in that scenario, they were able to learn 5 things that they just knew from then on out. And so if we change our conditions a little bit, we should end up learning more that sticks with us for the long run.